The use of green-colored wire as hot conductors, even when taped, is a violation of the National Electrical Code. According to NFPA 70, also known as the National Electrical Code or NEC, specifically Article 310.15b3, identified conductors shall not be used for grounded conductors or for equipment grounding conductors. Article 100 of the NEC defines identified conductors as conductors that have distinctive markings to identify their use. Green is exclusively used to identify equipment grounding conductors. Therefore, green wire cannot be repurposed for use as hot conductors. The primary purpose of the National Electrical Code requirement is to prevent the accidental or unintentional use of green wires as hot wires. Green wires are specifically reserved for equipment grounding conductors. These conductors are designed to safely carry fault current to ground. If green wires were to be used for hot conductors, this creates a significant risk of electrical shock or fire in the event that they are accidentally or inadvertently connected to ground. To ensure compliance with the National Electrical Code and to maintain electrical safety, it is important to remove the all green-colored wire that has been improperly installed. This wire should be replaced with conductors that are properly identified for use as hot conductors. Acceptable colors for hot conductors include black, red, or blue. To further ensure proper identification and prevent confusion, the conductors should be taped or labeled at all termination points and within enclosures. This practice helps to clearly indicate their intended use as hot conductors and not as equipment grounding conductors. By following these guidelines, the risk of electrical hazards is minimized and compliance with the National Electrical Code is maintained. It's crucial to understand the fundamental principles behind the NEC color coding system for electrical conductors. The system is designed to provide a clear and standardized method for identifying the purpose of each wire within an electrical system. The use of specific colors for different types of conductors is not arbitrary. It is based on years of experience and best practices in the electrical industry. These best practices are designed to minimize the risk of accidental misconnections and ensure the safety of people and property. The color green, with or without yellow stripes, is universally recognized as the color for equipment grounding conductors. These conductors provide a low impedance path for fault current to return to the source in the event of an electrical fault. This path is crucial for the proper operation of overcurrent protection devices such as circuit breakers and fuses. The equipment grounding conductor ensures that these devices trip quickly and safely, interrupting the flow of current and preventing electrical shock or fire. When green wires are misused as hot conductors, the integrity of the grounding system is compromised. This can have serious consequences, as it can create a situation where electrical equipment is not properly grounded, and the risk of electrical shock is significantly increased. Furthermore, the accidental connection of a hot conductor to a grounded surface can result in a short circuit, which can cause damage to equipment, start a fire, or even result in serious injury or death. The National Electrical Code provides detailed requirements for the installation of electrical wiring, including the proper identification of conductors. These requirements are not merely suggestions, they are mandatory rules that must be followed to ensure the safety of electrical installations. Failure to comply with these requirements can result in fines, penalties, and even legal liability. In addition to the color coding requirements, the NEC also specifies the types of insulation that are permitted for different types of conductors. The insulation must be rated for the voltage and temperature of the application and must be resistant to moisture, chemicals, and other environmental factors. The proper selection and installation of conductors and insulation are essential for the safe and reliable operation of electrical systems. When working with electrical wiring, it is crucial to always follow the requirements of the National Electrical Code and to consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it is always best to err on the side of caution. Never attempt to perform electrical work unless you are properly trained and qualified. Remember that the safety of yourself and others depends on your knowledge and understanding of electrical safety principles. In the specific scenario described, the use of all green-colored wire for hot conductors is a clear violation of the National Electrical Code. The fact that the wire is being installed in polyvinyl chloride or PVC conduit does not change this requirement. The NEC applies to all electrical installations, regardless of the type of wiring method used. The practice of taping the green wire to indicate that it is being used as a hot conductor is also not acceptable. The NEC requires that conductors be permanently identified by their color. Tape is not considered a permanent form of identification and can easily come loose or be removed. To correct this situation, the all-green colored wire must be removed and replaced with conductors of the proper color. Black, red, or blue wires are typically used for hot conductors in 120 volts or 240 volt systems. The neutral conductor is typically white or gray. The equipment grounding conductor is always green. When installing new wiring, it is important to use the correct color coding from the outset. This will prevent confusion and ensure that the wiring is properly identified in the future. It is also a good practice to label all conductors at termination points to further clarify their purpose. Labels can be applied using a variety of methods, such as wire markers, tape, or printed labels. In addition to the color coding requirements, the NEC also specifies the size of conductors that are permitted for different applications. The size of the conductor must be adequate to carry the load current without overheating. The NEC provides tables that list the ampacity of different sizes of conductors. Ampacity is the maximum amount of current that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. When selecting conductors for an electrical installation, it is important to consult these tables and to choose a conductor that is appropriately sized for the load. It is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The NEC provides guidelines for minimizing voltage drop in electrical circuits. In general, it is recommended that the voltage drop in a branch circuit should not exceed 3% and the voltage drop in a feeder circuit should not exceed 5%. To minimize voltage drop, it is important to use conductors that are large enough to carry the load current and to keep the length of the circuit as short as possible. When working with electrical wiring, it is always important to follow safe work practices. These practices include energizing the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. It is also important to be aware of the potential hazards of electrical work, such as electric shock, arc flash, and electrocution. By following safe work practices and by being aware of the potential hazards, you can minimize the risk of injury. In summary, the use of all green-colored wire for hot conductors is a violation of the National Electrical Code. This practice can create a dangerous situation and should be avoided. Always use conductors of the proper color for their intended purpose and follow safe work practices when working with electrical wiring. Remember the importance of the equipment grounding conductor. The equipment grounding conductor, or EGC, plays a vital role in electrical safety. It provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices like circuit breakers and fuses to quickly interrupt the circuit during a fault condition. This rapid interruption minimizes the risk of electrical shock and fire. The green color, with or without yellow stripes, is universally recognized as the identifier for the equipment grounding conductor. This standardized color coding helps prevent accidental misconnections, which could compromise the safety of the electrical system. When a fault occurs, such as a short circuit between a hot conductor and a metal enclosure, the equipment grounding conductor provides a path for the fault current to flow back to the source. This high current flow triggers the overcurrent protection device to trip, disconnecting the circuit and preventing the metal enclosure from becoming energized. Without a properly installed and functioning equipment grounding conductor, the metal enclosure could remain energized at a dangerous voltage level, posing a significant shock hazard to anyone who comes into contact with it. The size of the equipment grounding conductor is also critical for its effectiveness. The NEC specifies the minimum size of the EGC based on the size of the overcurrent protection device protecting the circuit. The EGC must be large enough to safely carry the fault current without overheating or melting. Proper installation of the equipment grounding conductor is essential for its effectiveness. It must be securely connected to all metal enclosures, equipment, and other conductive parts of the electrical system. The connections must be made with approved connectors and methods to ensure a reliable and low impedance path for fault current. The equipment grounding conductor should also be continuous throughout the circuit. It should not be interrupted by switches, fuses, or other devices. Any splices or connections in the EGC must be made with approved methods that maintain the continuity of the conductor. In addition to providing a path for fault current, the equipment grounding conductor also helps to reduce electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive electronic equipment and can even cause damage. By providing a low impedance path to ground, the EGC helps to dissipate EMI and prevent it from interfering with electronic devices. The National Electrical Code contains specific requirements for the installation of equipment grounding conductors in various types of electrical systems. These requirements cover everything from the size and type of conductor to the methods of connection and installation. It is essential to follow these requirements carefully to ensure the safety and reliability of the electrical system. In some cases, the equipment grounding conductor may also serve as the grounding electrode conductor. The grounding electrode conductor connects the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to earth, which helps to stabilize the voltage of the electrical system and provides a path for lightning currents to dissipate safely. The size and type of grounding electrode conductor are also specified in the NEC. The grounding electrode conductor must be large enough to safely carry any fault current or lightning current that may flow through it. It must also be protected from physical damage and corrosion. Regular inspection and testing of the equipment grounding system are essential for maintaining its effectiveness. The connection should be checked for tightness and corrosion, and the continuity of the EGC should be verified. Ground resistance measurements can also be taken to assess the effectiveness of the grounding electrode. Any problems with the equipment grounding system should be corrected immediately to ensure the safety of the electrical system. The NEC also addresses the use of isolated ground receptacles. Isolated ground receptacles are designed to reduce electrical noise and interference in sensitive electronic equipment. They have a separate grounding conductor that is isolated from the normal equipment grounding conductor. Isolated ground receptacles should only be used when specifically recommended by the manufacturer of the electronic equipment. They should not be used as a substitute for properly installed and functioning equipment grounding system. In summary, the equipment grounding conductor is a critical component of electrical safety. It provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to quickly interrupt the circuit during a fault condition. The green color is universally recognized as the identifier for the EGC. Proper installation, sizing, and maintenance of the equipment grounding system are essential for ensuring the safety and reliability of the electrical system. Remember, electrical safety is paramount. If you are unsure about any aspect of electrical wiring or grounding, consult with a qualified electrician. They can provide expert advice and ensure that your electrical system is safe and compliant with the National Electrical Code. The information presented here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.